Shall we start the next session? Hello? Yes, sir. Okay, thank you. Hi, sir.
A very good morning to one and all. I am Dr. Himanshu Mishra, HOD Mechanical Department of Mechanical Engineering Institute of Rural Technology, Prayagraj. It is really a matter of pride and privilege to introduce our guest of honor and first speaker of today's FDP session, Professor RAJEEV Tripathi. Professor RAJEEV Tripathi sir is currently working as a director, Motilal National Institute of Technology, Prayagraj. He did his BTech in Electronics and Communication Engineering in the year 1986 from University of Allahabad and Masters in Communication System in the year 1992 from University of Allahabad. And if you talk about his doctoral degree, he has obtained his doctoral degree from University of Allahabad in the year 1992, and his area of research was interconnection networks and switching aspects. It is really a matter of proud and privilege to introduce Dr. RAJEEV Tripathi sir for this session. Next, if we talk about his area of research, some of his area of research includes wireless and mobile communication, ad hoc networks, cognitive radio networks, wireless sensor networks, vehicular communication, that is intelligent transportation systems. These are some of his area of research where you will find his expertise. He is the professional member of IEEE, Life Fellow member of IETE, Institute of Engineers India, Indian Society of Technical Education, Indian Institute of Public Administration. Professor Tripathi is having a rich blend of academic as well as administrative experience. Some of his prominent achievements are, he has worked as professor in charge training and placement at MNNIT Allahabad. He has also worked as a head of department, electronics and communication department, dean academics in NIT Allahabad, chairman SPGC at NIT Allahabad, the coordinator of quality improvement program, that is QIP at NIT Allahabad, and faculty in charge communications at NIT Allahabad. He has also served as vice president at NIT Allahabad. His achievements are countless. In research field, he has supervised, as of now, he has supervised 16 PhD theses, 2 of which are undergoing, and he has supervised 75 master's theses and 100 theses of graduation students. If you talk about his research publications, as of now, he has 94 peer-reviewed publications in various international journals of repute. And more than 8 books he has authored. And more than 90 conferences proceedings he has done.
I think this much is enough.
We are really honored to have Dr. Tripathi sir, and his achievements are countless. It will take a complete day to find out his complete achievements.
ठीक है डॉक्टर साहब.
Thank you, sir. Thank you. Let's welcome Dr. Tripathi, sir, for his session. Thank you, sir.
चलिए, good morning, all of you, all the distinguished participants and the coordinator, Dr. Yateen, for introducing me. Well, let me see if I can share something. अच्छा, इस पर शायद मैं लिख नहीं पाऊंगा. एनीवे, चलिए ऐसे ही बात करता. Okay, so I'll try to am I audible and visible both?
Yes, sir. You are audible, sir, and now visible also, sir.
कुछ मैं शेयर करने की कोशिश कर रहा था, but anyway, there is some issue, so I'll talk like this only. First of all, as I said in the morning, that I like interactive sessions, and in case any problem, any confusion, any doubt, feel free to ask the question at that point of time only, immediately, right? Without any hesitation. Now, since this is focused towards electronic circuits, ये फिर कुछ होने लगा.
Nothing, sir. Screen has been shared.
Okay, so since this program is focused towards electronic circuits, so I hope that all the participants are from electronics background. What we need to see is whenever we are designing any electronic circuit, we must have the idea for what reason, for what application, for what use we are going to design the circuit. And one of the very basic component, I will be starting, basically, I will be talking in two different parts. One will be from the basics and another will be on the challenges of what we are facing today as a design engineer in general and specifically to electronic circuit design. So if I start this with a couple of basic fundamental questions, that any device, any active device, say for example with a very basic device, transistor, why we need to bias the transistor? Anybody would like to just answer it?
Hello, good morning, sir.
Yes, please.
Sir, I am Professor Sushma Punde from Nashik, Maharashtra. So according to my fundamental knowledge of transistors, we can use our transistors in either as a switch or maybe as an amplifier. So whenever we want to use it as maybe switch, we have to apply certain biasing, maybe forward biasing the emitter base junction and reverse biasing the base collector junction will imply the transistor to work and amplify. So this is what I mean, sir.
If we don't bias it, what will happen?
So we won't be able to operate it.
Why? Why we won't be able to
Because
operate?
there will be initial inertia, there will be initial, uh, initially the transistor has its own depletion region.
So depletion region, let it be. What exactly biasing does? Does it remove the depletion region?
Yes, of course. If the region is followed by it, it will make the required current to flow.
It's basically a junction potential which further restricts. Of course, junction potential is developed on the basis of the depletion region, and it further means prevents the movement of charges
Yes,
from one side to another side.
yes.
So, in order to counter that potential barrier, which is the main cause of restriction of movement from one side to another side, we need to bias the transistor for a smooth functioning of the transistor. Right? That is the basic thing. One more, these are just a brush up type kind of interactive discussions. I'll not say question answer, it's an interaction. To minimize the width of depletion, somebody has answered. Uh, if we have this Wien bridge oscillator, because the topic also talks about modeling. If we design a Wien bridge oscillator, we don't use any input. We just use, say, for example, very basic thing, 741 and with a related circuit, and it starts oscillating with a very good sine wave which is coming out. Without input, how this is oscillating? And we have designed the circuit in such a way that it will operate. If there is a minor mathematical difference or deviation, it may not work. But if the similar circuit, if the similar configuration, we put it on a simulator, will it work? P-Spice or something. Will it oscillate? It may not oscillate because the model which you have done it, that's in a perfect and ideal condition. And why in the circuit it oscillates? It oscillates on the basis of some characteristic of that operational amplifier device which you have used, and that characteristic is called your output offset voltage. And output offset voltage, you are getting it without applying any input. That's as per the definition of output offset voltage. And when it is sent to the feedback loop, it gets amplified. Waveform is idealized as per the relationship of resistance and capacitances which you have applied as per your mathematical model, and it will work. That's how the basic principle of operation of your normal Wien bridge oscillator is on the basis of feedback signal. Now, if you apply the same circuit On the simulator, it may not work because on the simulator, you have the ideal conditions, and under the ideal conditions, the ideal value of the output offset voltage should be 0, and thereby you are not getting any output. You just try it, and you need to give certain trigger voltage at some point in the circuit, then only it will work. Now, that is something, these are some of the examples which I am trying to instigate your thought process on the basic functionalities of the devices which we are going to use as a part of our circuit. And unless and until we know the basic behavior, basic characteristic of the device, we cannot use it properly. Now, if I am going back to the design part, which I started during my initial talks, for any design related issue, we need to define certain set of parameters which will form the design specifications. If I say, for example, that I am a layman and I am coming to an expert of the area, and I say that I need a communication link. Similarly, somebody can come to you and say that I need a circuit for this particular application. Now, as a layman, I am there. You are expert of communication engineering. What questions you are going to ask from me? This is a very basic fundamental things. It does not require the expertise of communication. But if you know the basics and fundamental things of communication engineering, you can ask the question from a layman. As I said, I'm not a technical person. I don't know the technicalities. So please don't use the technical terms. Any idea? Okay, first of all, you would like to know for what application you want to have a communication link. And application means maybe voice, maybe data, maybe video, transmission. And as per definition, I would like to just remind you that communication is the process by which we transfer the information from one point to another point. And this one point from where the communication is likely to start, that is called source or transmitter. And another part where the connectivity is required, there probably you talk in terms of destination or the receiver. So the first question is that what is your application? What you would like to transmit? And from here, and of course, the second question, the second important input which as a designer you would like to have is that what? Designer cost पूछता है कि नहीं? Is he interested to know how much money I will be able to invest? And let me tell you, the cost is the phenomena which is applicable to all the kinds of design. Whether you talk about communication link, or you talk about electronic circuit, or you talk about mechanical systems, सब जगह पैसे का खेल जरूरी है समझना. Because the amount of money and the reliability, that is where you need to optimize. Reliability or efficiency. So you need to know the money, how much money you will be able to spend. If I say that my budget is on the lower side, you may say as a designer that, well, within this limit, I will design the link, but definitely it may not give you the performance up to that level. Now again here I am putting another, just leaving this point here, I am saying another thing which is commonly used but not properly understood. People talk in terms of performance, people talk in terms of efficiency, people talk in terms of quality of service of any design or any system. But I say that all these terms, whether you are talking in terms of quality of service or you are talking in terms of performance or any such terminology which you are using, this is vague term. Unless and until you specify, as I said, in terms of design specification parameters and their corresponding values earlier, the same thing applies here. Unless and until you specify certain set of parameters, their corresponding values, and those values should be primarily categorized into three domains. One is acceptable value, another is preferred value, and third one is totally unacceptable value. So a set of parameters, their corresponding values in three domains, that will specify the performance. And many times a system designer, one of the basic and fundamental thing is that the designer has to do the lot of optimization. It is basically the optimization issue. Of course, after selecting the, after having visualized, conceptualized the design on the basis of specification parameters, after finalizing the components, now in terms of performance, you need to optimize. And this is equally valid to all the different kinds of design. Whether you are talking about communication system design, or you are talking about electronic circuit design, or you are talking about mechanical or electrical system design. And what I mean to say by optimization, that depending upon your application, on one side, you wish that this particular performance parameter should be very good. But when I am designing the system, it's quite possible that in order to make a specific parameter very good, I am compromising with another parameter. And that is where we need to see whether I am allowed to compromise that parameter or not. If I am allowed to compromise, then up to what level? I'll request those who are not speaking, please mute their mics. Mr. Hussain. Yeah. Yatin ji, please mute your mic. So, coming back to the point that we have to be very careful while designing any system that what optimization you are doing, you are getting the better performance in terms of one or two parameters at the cost of some other parameter or other set of parameters. Acha, in general, what we see, and I'm not going specific to electronic circuits. I'll come back to electronic circuits later. This, whatever I'm talking here is, I'm talking in terms of general design issues. आप किसी भी any such kind of system design, you may have come across the term weight function, cost function, or any similar kind of terms. Have you come across anybody? Yes or no? Yes. Somebody has answered yes. Now, what is this weight function? What is this weight function? What is this cost function or similar kind of term? And yet another related question is that whether this weight function or cost function is a standard one, we can apply anywhere. Any idea? Remember one thing, it's basically a numerical value which you may have come across. used in some integration. It's a numerical value. That means there is a very specific relationship and the values assigned, which gives you sorry, I could not get some answer. Okay, first of all, tell me, right? So there is somebody has answered rightly that there is no standard weight function or cost function. You need to design the weight function and cost function, whatever it is. And it is basically a combination or a relationship of certain parameters, which is your mathematical relationship. And that is where you do all the different kinds of exercises. And any system performance is primarily controlled by weight function. And let me tell you, many times I come across such situations where in master's thesis or in PhD thesis, people have used the term weight function, assigning different values and showing the excellent system performance. When I ask them, what is the justification of what is weight function which you have used, what is the expression, and what is the justification? In 95% cases, they are not able to explain. Now, where the problem is, again, I am deviating. I'll come back to the design problem of communication system design, which I started. I'll come back to that again. Now, where is the problem? The problem lies for any such kind of design. We use three different mechanisms. One is mathematical modeling, another is simulation, and third one is practical implementation. These are the basic three ways by which we realize our concept, whatever we have visualized, whatever we have conceptualized. And primarily we try to see that if something I have obtained using one tool that is matching with the results using another tool, we say that this idea is verified. And in most of the cases, the practical implementation becomes difficult or more challenging. So what we do, we go for mathematical modeling and followed by simulation. Now the things are deviating. First, people go for simulation because it becomes very easy for them. You have a simulator where you have n number of options available. You can select from the library this, run the simulator, get n number of graphs without exactly knowing what exactly that graph means, what is the interpretation of that graph, and you come out with the some kind of conclusion. This is one part. Another part is the mathematical modeling, and in that mathematical modeling you need to do good amount of mathematics, and for that you need to be well versed about the mathematical tools, the statistical tools, going theory, random process in the area of communication, and maybe different other mathematical models, standard mathematical models which are already available. You should have a clear picture of whatever you have designed, and on the other side you should know the different kind of mathematical tools available. You should be reasonably good to identify which tool will be applicable for this kind of scenario. So there, more work is required, and many times you may not enjoy that. So you start with the thing कि आइडिया है, कुछ है, सिमुलेटर है, और हमने कुछ कर लिया, ग्राफ मिल गया, उस ग्राफ का कुछ इंटरप्रिटेशन ड्रॉ कर लिया, and we have tried to write a research paper and that paper is published. I am happy, though I don't know what exactly that result means, though I don't know exactly what graph what interpretation of that graph is, but I am happy that it has been published. Where it is published, that's a different story. So what I mean to say that today, in majority of cases, simulators are dictating our research. You have designed, you have conceptualized something independent of the simulator. After your thought process, and after that, you went to search the simulators, you found some simulator, but you have seen that that particular simulator is not able to support your ideas or the issues which you have conceptualized. Because it's quite possible that a group or individual who has developed that simulator may not have been able to visualize on those dimensions which today you are able to visualize. So if you are stuck up under such situation, what normally you do? Normally you try to compromise with your ideas, and you try to compromise it up to the extent that the simulator available to you is supporting, start supporting. And then you are happy. you don't have any regret that you have compromised your concept, you have compromised your visualization, whatever you have done. And after that, you do the similar kind of thing which I have just now explained, that you go to the library, select the different combinations, get a number of graphs, and happy man. So please don't do that. If you have started enjoying your research, if you want to enjoy your research, which is very important for your professional career, if you are going in teaching and research as a career, don't compromise the idea. If you don't get, try to write your own simulator. Then only you will be happy. Then only you will be in a better position to know what exactly that simulator is doing. And if you are not writing, if you are happy with the simulator which you have got, then try to know how that simulator works. And unless and until you know, many times, I see in the case of VLSI design, people get timing diagram, transition diagram, and when I ask the question that, hey, here is your timing diagram, here is your circuit, now tell me at one transition how this circuit is behaving in the physical mode. Blank. No answer. Because they don't know what the input, under what input condition this transition is taking place. Under what noise condition this waveform is getting deterioration. And what is that source of noise? And unless and until you know that source of noise, which is responsible primarily for the deterioration of your waveform, you cannot do anything to remove it. And then you start asking the question, okay, how to improve this waveform? Then all sorts of guesswork will start coming. So please don't do that. If you want to really enjoy your research, if you want to really enjoy your research profession, or for that matter, teaching profession, because it's a faculty development program, so that's why I'm saying in that direction, then you need to involve yourself. So don't let your simulators dictate your research. Simulators are there to help you, to assist you in your research. Now, coming back to the problem which I started with the communication link design, I left the point by the way of asking that I am a layman, I have come to you for a communication link design. What are the inputs which you would like to have from me? And one of the input, I in fact told that you need to know the type of information which you would like to transmit from one point to another point, that source to destination. Second point, I said that cost is important, because as you go on increasing the cost, maybe, I don't say that it is always fact, but maybe your communication link will be more reliable. What is another point which you would like to know from me? Any idea? Any idea? Another point which you would like to know, I'll tell you, the distance. What is the distance between source and destination? And the reliability from where I deviated, reliability in terms of communication link design is primarily defined in terms of delay, how much time it takes from source to destination, in terms of jitter. Jitter is variation in delay. If the delay is constant, and if the delay is not constant, there is a variation in delay, then what amount of jitter effect is there? And remember, this jitter effect is also important in electronic circuits also. It's not only in communication. Because in many complex CMOS circuits, today the problem is of jitter. Complex CMOS circuits, where from different inputs, from different sources, the different inputs are provided to one stage. Many times, jitter creates a problem. And this problem is being faced by VLSI design industry also. And of course, that's a different domain. I may come back to that issue. But let us not deviate now from this point. So, we talked about a couple of parameters, and we have come to the conclusion that this is the set of parameters on which we have designed the link. This is the ideal situation. Let's hope that nobody is going to open their mic now. Oh, it has started. Anyway, now we know that these are the set of parameters, these are their corresponding values, which I wish that at the end of the day, my communication link should be able to support this. Now, my next question is that once you have seen, you have got the specification parameters for this communication link design, what is the next step? Any idea? Those of you, I believe that everybody must have gone through the communication related courses. So this is not something which I am talking about out of box. So depending upon the type of information which you want to transmit, depending upon the distance, and of course, the third one also, the reliability, we try to select what type of medium which I should use. And there, in that selection also, the cost is also involved. So if you can see that for taking the decision on the selection of medium or channel, we have to consider all these parameters which I have just now told. And you cannot select the medium or channel unless and until you have the complete set of mediums, all the available kinds of mediums, their basic characteristics, their approximate cost. So that is one set of database which you need to have in your mind. And on the other side, you have the set of specifications, and based on that, you select what type of medium you are going to use in this particular design. Similarly, in all other system design, you need to know, you need to have the database of the components which may be required, their performance, their limitations, their drawbacks, and unless and until you have all those kinds of information, you won't be able to select a particular component for your design. And coming back to the communication problem, once you have selected the medium or channel based on the characteristic of that medium or channel and your design specification, now you can select what type of transmitter, what type of receiver you are going to design. And in order to select the transmitter design first, in order to select that, you need to know the different components of the transmitter. Again, the same thing. You need to know the different types of modulation schemes. You need to know different types of multiple access schemes. You need to know different types of encoding schemes. And then only you can finally design the transistor. You can finally design the transmitter. Any communication. My time is over, is it?
Sir, sir, as you think, sir, if you have time, then it is better to us to listen to you, sir.
No. Tell me what is the time which has been assigned to me?
Sir,
Maybe 10 minutes more? 10 more minutes?
yes, sir. Yes, sir.
Okay.
10 minutes, yes, sir.
Okay, okay. No, I was under the impression that it will go up to 115 something. Anyway, I'll just try to wind up. So coming back to the issue, so any design, anything, you have to be very clear in your concepts, what you are visualizing. You have to be clear what type of simulators you are using, what are the limitations of those simulators. Today, as I said in my opening lecture, that today it is very challenging from, especially for electronic engineers, to come out with the combination of different circuits for different kinds of application at low cost with good efficiency, and there the development advancements in the area of material science, in the area of VLSI technology, that has played a very important role. Now, the advances in the area of circuit design is people are talking about reconfigurable circuit design, and the concept, basic concept of reconfigurable circuit design is that you will have one single hardware, and just by changing the set of control signals, the same hardware can be used for different applications. Say, for example, in terms of your filters, you will have one circuit, and with the change in the control signals, you can use the same circuit for band pass filter, low pass filter, high pass filter. This I'm just giving you a very basic example. The complex circuits, there also you need to identify, and how it is done. How it is done. You just need to see all the family of a circuit which you want to integrate, which you want to have a kind of reconfigurable VLSI. You just try to identify the basic components, and in most of the basic components, it's primarily inverter or a single MOS transistor, BJT transistor, or hybrid kind of combination of MOS and BJT. That depends upon the kind of technology which you are going to use. With that basic unit, you just need to see that how many minimum number of units, basic unit, can be used, and then with different combinations, with the different set of control signals, what combination will be activated inside the circuit, so that to give you the output of the desired circuit. Now, when you are talking about a circuit design, again, how many of you are familiar with the DC analysis and AC analysis of any circuit? I'll take an example of normal operational amplifier, which is your, which may be your BJT or maybe your CMOS. If you try to implement that with the discrete components, you will be using the different discrete components in order to get the desired characteristic of that operational amplifier. And if you try to see the inside circuit, I'm just taking very basic component just to make you realize that what exactly is happening there inside. Because as a VLSI circuit designer, we need to see easy implementation of VLSI. And easy implementation of VLSI is if you have designed a basic component and you keep on repeating that, that's a very cost-effective solution. Instead of having different components and then trying to integrate them. Going back to the operational amplifier part, if you see the basic block of a difference amplifier, you need to bias the transistor on both the sides. And biasing again means that you need to give certain current, and that can be given with the help of your external resistance or means resistance along with the DC source. But if you do the DC analysis of that circuit, on the lower part of the circuit, you need to have a very high value impedance in order to get one of the very basic characteristics of the operational amplifier, that CMRR should be infinity. So for that, you need to have a very high impedance at the lower side. So what is required? You should have a constant input in terms of current. And another requirement is it should have high impedance. So as I was saying earlier, that you need to know the family of circuit and their basic characteristics, from where you can select which will suit your requirement. Then only you are an efficient and effective designer. So there is a circuit which is normally used, which is called current mirror, or you can say constant current source, which, as the name indicates, it gives you the constant current and it exhibits the high impedance. And that circuit can be realized with the help of the transistors. Either you are using BJT or you are using a MOS transistor in the different combination. So repetition you can have, and you can derive the desired characteristics which is required at that point, thereby minimizing your design complexity and getting the desired output. So that is how the design approach has to be. So what I tried to tell you, that you have to be careful while selecting your simulators. And since all of you are involved in the teaching and research process, let me tell you, if you start enjoying your research, automatically your quality of teaching will improve. And unless and until you are very clear in what exactly you are doing, and you are you are leaving that path easy going without understanding, as I said earlier, you won't be able to enjoy your research. So please use these concepts. Always ask yourself, what is your target? Why I am doing this? How it is done? If I am using something as a tool, what exactly that tool is doing? That improves your logical thought processing. Any questions, any clarification, any doubt, please feel free to ask. No questions? So I tried to instigate, I tried to tell you how to proceed towards your design issues. I tried to make you cautious about the tools which you are using for your design, which you are using for your research. I tried to name some of the things with some very basic examples, the challenges and the issues which a designer is facing. So if there is any question, any doubt, any clarification, please feel free to ask.
Any questions from the participant sides? No questions?
Thank you very much for providing me this opportunity to share some of my thoughts and the experience which may be beneficial for you. And I have tried to give you some input which may be considered in the subsequent days. Enjoy the sessions, have interactive session. Don't be like this, what you did in this session. And means because it's not possible to cover the complete details of any topic in the given limited time. So the only purpose, one of the important purpose of such kind of program is to generate an interest. And if, as I said, if the interest is generated, you can take it forward. So all the best. Good luck. Thank you.
Sir, thank you, sir. Good afternoon, sir. Good afternoon, our most valued invited guests and learned speakers, respected Professor Rajeev Tripathi sir, Director MNNIT Allahabad, and Mr. Professor, Director I.E.R.T, all other learned speakers, coordinators, Dr. Yatin Goro sir, and organizing committee members and all participants. Very good afternoon to you all. It's my privilege to propose a vote of thanks for this fruitful session. I, Pushpen Kumar Gupta, Assistant Professor in Electronics Engineering Department, on behalf of the Institute IERT Allahabad and the entire team of this FDP, this ATAL FDP, and on my own behalf, extend a very hearty vote of thanks to Professor Rajeev Tripathi sir for your important work and sharing with us your findings today. This topic is really very interesting. This eye-opening session covered many fundamental things like why we go for biting in the transistor and oscillator, basics principle of operation of oscillator, offset voltage, filters, basic element of communication, and importance of how any simulator works. Again, cost effectiveness and reliability are also two more important factors for any design system. This session also covered basics and advancement in designing in the field of devices and circuits and communication. I hope this session must be fruitful and helpful to all participants. Surely, these informative sessions will improve the research attitude, research ability, teaching skills of all the participants. Rajeev sir is really living godfather in the field of communication. I also want to thank all technical staff and other staff for organizing this FDP. Once again, thank you, sir, so much for giving your valuable time and such a nice session. Thank you, sir.
Thank you. Can I disconnect now?
Thank you, sir. It was a really a nice problem solving. The session was really a very problem solving, sir. Thank you, sir, for that. And I would like to request the all the participants to please. We will be again back at 2:30 p.m. on the same link. Thank you, sir.
Thank you. Thank
The
you.
next session will start at 2:30 p.m. and it will be taken by the Professor R.N. Mishra sir. He is a senior professor in MNNIT Allahabad Prayagraj in Electronics Engineering Department. Thank you. We'll be back soon at 2:30 p.m. The next session will start at 2:30 p.m. Thank you. So please fill up the feedback form. The feedback form has been sent on the message here. So please fill up the feedback form for this session. Thank you.